Alright RF warriors, we've designed the amplifier. Now it's time to actually build it. Let's walk through how to go from simulation to solder smoke. First, you finish your schematic. You've got your MIC stages selected, matching networks tuned, DC bias points calculated, and power splitters placed. Double check. Are all your ports 50 ohm matched? Are the DC blocks and bias tees in the right places? Are your power traces thick enough and grounded well? Cool. If yes, we move on. Now open up KiCad or Altium. Keep this checklist handy. RF traces are 50 ohm microstrip calculate based on your substrate. Use ground planes generously, stitch vias often. Keep MMIC output paths as short as your patience. Place bypass caps close, and I mean right next to the MMIC power pins. Route DC traces separately from RF paths. Keep heat dissipation in mind. Copper pores under the chip and thermal vias to the bottom. Send the board out for fab JLCPCB with HPARC or whatever flavor you like. Meanwhile, order your parts. MMICs, passive components SMD resistors, capacitors, inductors, power splitters, combiners, SMA connectors, voltage regulators or DC-DC converters, and yes, get flux. Lots of flux. Clear your bench. Plug in the soldering iron or hot air station. Put on your anti-static. Wrist strap. Don't fry those. $40 MMICs by sneezing on them. Time to build. Here's the golden sequence. Start with small passive 0402 or 0603. Caps and resistors first. These go around bias lines, decoupling, and matching networks. At the MMICs, align carefully. Tack one corner, then reflow the rest. Use hot air if needed. Solder the bias T parts, typically a capacitor and inductor, in a T structure. Make sure they're oriented right. Install RF components, combiners, directional couplers, and other microwave candy. SMA connectors last. You'll need them solid for test setups. So make sure ground tabs are well soldered. Check continuity and shorts, multimeter time. Power pins should not be shorted to ground. Mount heat sinks. Use thermal paste and screws if needed. Hot MMICs equals dead MMICs. Use a bench supply with current limit set. Power it slowly. Watch the current draw. No spikes. Good. MMIC not sizzling. Excellent. Now inject a signal and observe output gain using a spectrum analyzer. And that's how you assemble an RF power amplifier carefully, thoughtfully, and ideally without frying anything. Is it magic? Sort of. Is it awesome? Always. Now go impress your lab, your CAD, or maybe even the FCC.